Hello everyone. Before you start the lesson, please try this warm-up. Solve each equation. So of course by solve I mean figure out what the missing number is, x in each case. X divided by 2 is the same as 12 divided by 8. Or you can think of it as fractions. Something over 2 is the same as 12 over 8. However you want to think of it, try to solve. So pause the video, see what you can do, and then check back in. Many of you will have looked at the first one and thought, well, I know 2 times 4 gets me 8, so this number times 4 will get me 12. So working backwards, x would be 12 divided by 4. And many of you would have done that to figure out that x is 3 for the first equation. And that works. I want to show you cross multiplication as well. So this always works, even if the numbers are not so nice. 12 times x is the same as 3 times 20. That pattern always works whenever you're solving for an unknown in equivalent fractions. So it's called cross multiplying because you're multiplying the numbers that are across from each other diagonally. 12 times x is the same as 3 times 20. That's where this line came from. Now to solve for x, I've got to divide by 12. So that's what I do over here. So I do 3 times 20, and then I divide by 12, and I get 5 as my answer. And that works nicely here. This is an example where the numbers aren't so nice because I don't know what to multiply 2 by to get 9. So I can't just solve by inspection like I did up here. But I can cross multiply. 2 times x is the same as 5 times 9. So that's where this came from. To solve for x, I got to divide by 2. So 5 times 9 is 45. Divided by 2 is 22.5. Now you don't have to write out this step. You can actually skip. And I'll show you that with this next one. So I know that 5 times x is the same as 2 times 12. And I know I'm going to have to divide by 5, so why don't I just do it all in one step? 2 times 12 divided by 5. It gets me 4.8. Now, this math here, solving these equations, is basically what we're going to be doing in this lesson. It's going to look a little more complex because we're going to be doing trigonometry calculations, but the principle behind solving these equations and cross multiplying is what we're going to do today. We're starting the section of the course where we are solving triangles that are not right triangles. So up until now, when we've used sine, cosine, and tangent, we've been solving problems involving right triangles. They have a 90-degree angle in them. Sine law will allow us to solve problems that involve what we call oblique triangles. It just simply means there's no right angle in the triangle. So this is the sine law. It looks kind of weird. Just to remind you what these symbols mean, lowercase a versus uppercase a and all that. Uppercase letters are used for the angles. Lowercase letters are used for the side lengths. Notice that opposite sides have the same letter as the angle that they're opposite from. It's just that the side is lowercase and the angle's uppercase. So when I say a divided by sine a, I'm talking about this side length divided by the sine of this angle. And b divided by sine b is this side length divided by this sine of this angle, etc. This looks a little bit similar to what we saw in the warm-up where we have equivalent fractions, fractions that are equal to each other. This just simply means the ratio between a side and the sine of the angle that it's opposite from is the same for each pair of side with angle. And this works for any triangle, oblique triangles, which are non-right triangles, and also right triangles. This also works. So in this lesson, I'm going to show you how to use the sine law to calculate a missing side length and also a missing angle. So here's my first example for finding side lengths using the sine law. In this triangle, we know 2 angles. We know one side length. This is not a right triangle, so I can't solve for x using sine, cosine, or tangent. But I know that the 8 centimeter side is opposite the 45-degree angle, and x, the missing side, is opposite the 60-degree angle. So I do have pairs of opposites. So if I start with the sine law, a over sine A equals b over sine B equals c over sine C, I'm going to pick two what I call matching pairs. X matches up with sine 60, that's a pair, so make it into a fraction. 8 matches up with sine 45, that's another matching pair, make it into a fraction. And they're equivalent fractions, so they're equal to each other. Once you've made your equation using the sine law, this is actually the same as what we were doing in the warm-up. You can solve for x by cross-multiplying. 8 times sine 60 is the same as sine 45 times x. So if I want to solve for x, I can just skip ahead. 8 times sine 60 divided by sine 45, and that's where this came from. So this line here is just what I showed you in the warm-up. If you forget, you can go back in the video and rewatch my take-up of the warm-up. Once you do this in your calculator, 8 times sine 60 divided by sine 45, you get about 9.8 centimeters, and that's how long this side length is. So to answer these questions on the side, how do you know which numbers to put where? Well, remember, side lengths are the lowercase numbers, so that's why I put x and 8 on the top, because they're the side lengths. And the angles are the capital letters. And remember, A and A are opposites, so if I put x on the top, the opposite is the 60-degree angle, so that goes on the bottom, sine 60. And how is solving the equation similar to what you did in the warm-up? Well, I solved by cross-multiplying, just like I did in the warm-up. Now, one issue that I see all the time is right here. People forget that it's sine 60 and sine 45. A lot of people just put 60 and 45. So to solve for x, they do 8 times 60 divided by 45, and they get a number that's not right. So just watch out. In the sine law, it says sine, that has to be there. So here's an example where there's a triangle. I know two angles. I know a side length. And the question is, determine the length of side C. So let's first determine which side we're trying to find. Well, this is angle C, so directly across on the opposite side, this is side C right here. That's the side length we're trying to find. I also want to remind you that if you know two angles inside the triangle, you automatically know the third one. If you remember the rule or the law, every single triangle follows this law. The three angles inside the triangle add up to 180 degrees. So if you know this angle's 48 degrees and this angle's 25 degrees, you know that this angle has to make up the difference to get up to 180 degrees. So in this case, angle A has to be 107 degrees in order for all three angles to add to 180. Okay, so the question is, determine the length of side C. That's what you want to find. Why don't you pause the video and see if you can figure out how to determine that side length using the sine law. So pause, try it, and then check back in. Side C matches with sine 25. 36 matches with sine 107. Cross multiply 36 times sine 25, divide by sine 107, you get about 15.9 centimeters. So now here's an example of how you can find a missing angle. So this time I know two side lengths, I know one angle, and I'm trying to figure out this missing angle. Remember, you can't determine this angle by subtracting from 180 because you don't know what this angle is. So we have to use the sine law. Match up the pairs. We know that x matches up with 8 centimeters, 9.8 and sine 60 will match up too. That's where these came from. And cross multiply. Sine x is the thing that I don't know, so I will multiply 8 and sine 60 and divide by 9.8. Do that in my calculator, I get this. Now here's where it's different than the last example. Because we're trying to find the angle, I have to do this next step, the inverse sine. And you've seen this before when we were finding missing angles using sine, cosine, and tangent. We had to use the inverse sine or inverse cosine or inverse tangent. Well, here we're solving for sine x. So if sine x equals 0.7, then x equals the inverse sine of 0.7. And I'm using more decimal places just to be more precise. I would like you to use at least 4 decimals if you have to retype that in your calculator. If you have a nice calculator though, do this in your calculator. 8 times sine 60 divided by 9.8. You'll get a screen full of digits. Don't clear the screen. Just put in the inverse sine. And if you're not sure how to do that on your calculator, please let me know. You should get an answer of 45 degrees. So if you're not getting 45 degrees when you do this calculation, you have to ask for some help with using your calculator. So anyway, start the same way. Find your matching pairs, your pairs of opposites, make your equation, cross multiply to solve, and then because you're finding an angle, do the inverse sine at the end. This question says, solve the triangle. We know 2 sides, we know 1 angle. When the question says solve the triangle, it means you need to figure out all the missing pieces of information, the missing side length as well as the 2 missing angles. I'm going to leave this for you to try on your own, so pause the video, see how much of this you can solve, and then check back in. Here's my solution. If you need to take more time to look through it, just pause the video and take a look. If you have questions, you need to let me know. And here's a question. Solve for h. H is the height of the big triangle. Now you can use sine law and any previous trigonometry that you've learned to solve this problem. Why don't you challenge yourself, pause the video, and see what you can come up with. The answer should be 38.9 meters. If you got something different, let me know and we can figure out what the issue is. Otherwise, it's time to practice. You have a worksheet called Sine Law Practice. You can get started with that. And if you have any issues, please reach out.